Hi everyone. So welcome back to our video lectures on Introduction to Numerical Analysis. We have already discussed interpolation and Newton's formulae for interpolation. Let us recall the formula for Newton's formula for interpolation. Newton's forward interpolation formula is applied when there are n values x0, y0, x1, y1 up to xn, yn of a function f of x is given. We are approximating that function with a polynomial yn of x. Yn of x will be given by y0 p delta y0 plus p times p minus 1 by 2 factorial delta square y0 up to p minus 1, p minus 2, p minus n plus 1 divided by n factorial delta to the power n y0, where delta is the forward difference and p is x minus x0 divided by h. While applying Newton's forward interpolation formula or Newton's backward interpolation formula, our assumption is the points are equally spaced. That means x0, x1, x2 up to xn are equally spaced. There are certain values of a function f of x is given in the following table. You are supposed to find the value of the function at 301. Can we apply Newton interpolation formula here? If you look into the table, you will see that the values of x are not equally spaced. The values of x are 300, 304, 305, 307. They are not equally spaced. Then what is our method? That is what we are going to discuss today. We are going to discuss Lagrange's interpolation formula, its illustration, theory, and some exercise problems. Before stating Lagrange's general interpolation formula, we will be discussing very simple cases, that is a first degree polynomial and a second degree polynomial. Using these two ideas, we will generalize to the nth degree polynomial. Now let us see how we can do this problem. In our first problem, given 2 points x0, y0 and x1, y1, we are supposed to find the first degree polynomial L1 of x. Since it is first degree, we will write its general form as a0 plus a1x. That L1 of x should satisfy L1 of x0 is equal to y0 and L1 of x1 equal to y1. So substituting x equal to x0 and x equal to x1 in L1 of x and using this condition that L1 of x0 equal to y0 and L1 of x1 equal to y1, we will get two equations, a0 plus a1 x0 equal to y0 and a0 plus a1 x1 is equal to y1. Now this is a system of equations. We can express this in the matrix form and find the values of a0 and a1. So using your simplification of matrices, you can find L1 of x is equal to L0 of x y0 plus L1 of x y1, where L0 of x is x minus x1 divided by x0 minus x1 and L1 of x is equal to x minus x1 divided by x0 minus x1. So by substituting x equal to x0 and x1 in this L0, we can tell that L0 of x0 is 1 and L0 of x1 will be 0, because L0 of x0, x0 minus x1 by x0 minus x1, it will become 1. L0 of x1 is x1 minus x1 divided by x0 minus x1, which is 0 by x0 minus x1, it will be 0. In general, we can write Li of xj is 1 when I equal to j and 0 when I not equal to j. To get more clarity on what we have done, we will go for the second degree polynomial. When we will apply second degree polynomial? When there are three values are given. That is x0, y0, x1, y1, x2, y2 are 3 points of a function. We are supposed to find the second degree polynomial. The second degree polynomial general form is a0 plus a1x plus a2x square, and it should satisfy L2 of x0 should be y0, L2 of x1 will be y1, L2 of x2 will be y2. So we will get a system of equation as a0 plus a1x0 plus a2x0 square equal to y0, a0 plus a1x1 plus a2x1 square equal to y1, a0 plus a1x2 plus a2x square equal to y2. Its metric form will be 1 x0 x0 square, 1 x1 x1 square, 1 x2 x2 square, a0 a1 a2 is equal to y0 y1 y2. Simplifying, we can write the polynomial L2 of x as L0 of x y0 plus L1 of x y1 plus L2 of x y2, where L0 of x is equal to x minus x1 times x minus x2 divided by x0 minus x1, x0 minus x2. L1 of x is equal to x minus x0, x minus x2, x1 minus x0, x1 minus x2. L2 of x is x minus x0, x minus x1, x2 minus x0, x2 minus x1. Looking at this L0 of x, L1 of x, L2 of x, you can see a pattern here. In the L0 of x, in numerator, there is no x0. Whatever terms are in the numerator, the same terms are there with x replaced with x0. Similarly, the same thing happens for L1. Numerator, you will not find x1. Denominator, the same term of numerator, but x is replaced with x1. The same thing is for L2 of x. So here also we can tell that Li xj will be equal to 0 when I not equal to j and equal to 1 when I equal to j. Looking at this one, we will go for the general Lagrange's interpolation formula. So we need a nth degree polynomial ln of x. It should satisfy ln of xi is equal to yi for I equal to 0, 1, 2, 3 up to n. So you have to assume that your polynomial is a0 plus a1x plus a2x square plus an xn, and substitute various values. You will get a system of equations, and you solve the system of equations, and you will get ln of x is equal to L0 of x y0 plus L1 of x y1 plus etc. plus ln of x yn, where L0 of x is given as x minus x1, x minus x2 up to x minus xn, divided by x0 minus x1, x0 minus x2, x0 minus xn. So you can see the same pattern which we have discussed earlier. You can identify the same pattern here also.